This is Algebra 2B, Lesson 8.2, Law of Sines. So we're going to start with non-right triangle. I guess it does work for any triangle, including right triangles, but we're looking at non-right triangles now. And we're going to label our three corners with capital letters, and then we go straight across to the opposite side from those angles, and we're going to use the exact same letter but the lowercase instead. So across from capital A is lowercase a, from capital B is lowercase b, and from capital C is lowercase c. Always capitals for angles and lowercases for sides. Then our law of sines follows the sine of angle A over side A is equal to the sine of angle B over B is also equal to the sine of C over C. Now, this is the rule that we would use generally when we have a non-right triangle, but we know two. That means we know AA, or BB, or CC. We know two. We know a side and the angle directly across from that. So let's try our first example then. Example A reads, towers A, B, and C are located in a national forest. From tower B, the angle between towers A and C is 53.3 degrees. From tower C, the angle between towers A and B is 46.7 degrees. The distance between towers A and B is 4,084 meters. A lake between towers A and C make it difficult to measure the distance between them directly. What is the distance between those towers? So I added the A and the C because I know that there's a lake between them, and I'm going to throw a B on that third corner then. And remember what we talked about? That means that lowercase a is across from big A, lowercase b is across from big B, lowercase c is across from big C. And I'm going to add some of the numbers I see here. So the angle B would be 53.3 degrees. The angle C would be 46.7 degrees. And the distance between A and B, the distance between A and B is our C, would be 4084. Now, remember what I said, we need two something. So in this case, we do have two C's. We know big C and we know little c. And that's where we're going to start. We're going to start with the sine of the angle of which we know two values, right? We know two C's. So we're going to start with the sine of angle C, and we will put that over the length of side C. And then we're going to do another sine ratio, and we're going to do what we're trying to solve for then. Since we're trying to solve for little b, we're going to put angle B on the top there. Okay, so then we're going to go sine of the other angle that we know, which is 53.3 degrees. And we'll put that over the variable across, which is the letter B. Once we have fraction equal fraction, we have a proportion that we can solve using cross products. So that's going to be multiply diagonally, divide, and that will give us our answer. Okay, so that's going to be the sine of 53.3 degrees times 4,084, and then divided by the sine of 46.7 degrees. I'm going to go to my handy dandy here, and we will go with sine 53.3 degrees times 4,084 divided by the sine of 46.7. So make sure we're working our parentheses appropriately, right? Closing them after each of our angle measures. And that then tells me that the distance between them two lakes, which is side B, is equal to 4,499-ish meters. Let's try the next example. The next example is giving us a triangle and then just asking us to, hold on, it's not scrolling. Giving us an angle, a triangle, and then asking us to solve all the missing measures. So that means we're going to have to get side A and angle B and angle A. Just like with the last one, we're going to start with the two measures that we know. And in this case, we know the two C's. We know capital C, and right across from that is lower c. I'm also going to add a label here because this is capital B, which means if I go straight to the opposite side, I do have my little b. So sine of 122, sine of the angle we know, over its opposite side is equal to, and the only other number I have is a 5.4 on side B. Now be mindful that sides are going in the bottom, so that 5.4 is going on the bottom there. And I don't know the sine of angle B, so I'll put my variable on the top this time. With my proportion set up, we're going to do the same cross product situation. 5.4 times the sine of 122 divided by 18.5. Okay, and we'll go to the calculator. That is 5.4 times the sine of 122 degrees divided by 18.5. Now this is a little different than the first question because this isn't telling me the measure of angle B. This is telling me the sine of angle B. When we do this, we want to keep at least 4 decimals, 2475, because we need at least that many decimals when we go for our second step, which is to complete a sine inverse. So that is the sign with the little -1. Anytime we're looking to get an angle, we need a sine inverse. We're going to put those 4 decimals in there, and if you're using one of these calculators, that is a second sine, gets you the sine inverse, 0.2475. And then that actually gives me the angle of B, which is 14.3 degrees. Okay, now we only have one of the 3 answers that we're looking for. To get the next answer, we're going to think back to our geometry knowledge and remember that the 3 angles of a triangle always sum to 180 degrees. So to get the answer for capital A, we're going to do 180, which is the total of the 3 angles, minus the 2 values that we know. If we subtract the 2 we know from 180, whatever's left over will be the answer for capital A. So that tells me that the angle for capital A is 43.7 degrees. So we have one more answer to find, which is the measure of lowercase a. We're going to go back to our law of sines. I'm going to reuse the same ratio I started with, my sine of capital C over little c. So that's going to be sine of 122 over 18.5. And then now, because my goal is to find the measure of little a, I'm going to put that underneath the measure of capital A that I just figured out. And then again, we'll do our cross product to figure out the answer for little a. So that's going to be the sine of 43.7 times 18.5 divided by the sine of 122. And that points to my answer. So I'm going to try to squeeze that in right here. Sine of 43.7 degrees times 18.5 divided by the sine of 122. I'm going to go crooked to just make sure he fits in there. Okay? Sine 43.7 times 18.5 divided by the sine of 122 Make sure we're working our parentheses appropriately, and we end up with a 15. Let's go 15.1. And so now we have our three answers. We figured out little a, we figured out big B, and we figured out big A. And that is it for this lesson. Good luck on the exercises, and please let me know if you have any questions.